All right, so looking at the board, this is what our function looks like when it's just x squared, right? That is just our parent function right here. That's a regular one that starts at 0, 0. That's like y equals x. That would be a parent function. Now, I want to see the transformation that happens. I'm going to do it in vertex form. And so let's see what happens if I go 2x squared plus 2. What just happened there? The blue one is the one I just typed in. What happened from the red one to the blue one? It moved up how many? 2. What if I did it inside the parentheses? So here's the parent function. Here's the green one. What happened when I put plus 2 inside the parentheses? Which way? To the right or to the left? To the left. Because remember the parentheses is opposite. And so what if I did x minus 2? What way do you think it's going to go? To the right. And we can exit all these out so you can see. See how it went over right 2? What if I added plus 2 to that? What happened to it? Up 2, and it went right 2. What if I went minus 2? What happened to it? It went down 2. What if I did plus 3 here? Left 3. So today, that's basically all we're doing. These are transformations. So it's taking this original function right here and moving it around. So when we see it in vertex form, right? Remember we learned the vertex is the opposite of what's in the parentheses, but the same as what's outside here. What is our vertex looking at this? What's the opposite of positive 3? Negative 3. And this is the same. So see how our vertex is negative 3, negative 2? That's because we literally are moving it. Does that make sense? The last thing we're going to be doing is if we have a negative leading coefficient, what's going to happen to this guy? So what if I had a leading coefficient right here that's negative? What's going to happen to this? Negative Nancy. Do you guys see that? Now, the last thing we didn't learn is if we have a fraction that's going to be in front, like that, what happened between here and here? The blue one. What's the difference between the red one and the blue one? One's wider. So when it's a fraction, no matter what, because if it's negative, that just means it's going down. If it's a fraction, it's going to be wider. If it's a whole number, like 7, look what happened to it. It's really, really narrow, right? So it's actually the opposite of what you would think. A fraction you would think would be smaller, but it's actually getting wider if it's a fraction and narrower if it's a whole number. And so that's just showing you what it looks like, so it's not just a bunch of words. But today we're just going over transformations, which is we're figuring out what's going on from our parent function. So you guys are going to lift this up right here. And at the top, we're going to go through each letter and figure out what's going on in each letter. And so I'm going to start with A, which is our leading coefficient. Open it up. Yeah. And so you can write at the very top above it. Yeah, at the very top, just write leading coefficient. And so we know if our A is negative, we know it's going to be a negative Nancy like that, right? Is it going to concave up or down? What way is the arrow going? Down. Down. So we know that it's going to go facing down. Now, if A is a whole number, which put an absolute value there, because that means no matter if it's negative or positive, if A is a whole number or larger than 1, we know that it's going to get narrower. We know if it's a fraction, it's going to get wider. So that A tells us all of that. The only thing that leading coefficient tells us, we already learned that it tells us if it's a positive Patricia or negative Nancy, but it also tells us if it's narrower or wider. And so down below, you see that those boxes right here. We're going to be doing 2 examples. We'll go through it, 2 examples together, but I want to go through each one of these first. So the next thing I'm going to go over is the minus h right here. And so sometimes it will look like this. That means if it just says take the function, if it's plus h, which way am I moving? Did we figure out? Opposite, which is what? This is not the right. This one, plus h to the left. So this would be a shift to the left. If it's minus h, we know it's a shift to the right. And so we taught you the forms before so that you can see that opposite thing, why it's moving to the left. We also know, below, you're going to write this, we also know it's our x coordinate of our vertex. And for our brain buff, who can raise their hand and tell me the vocabulary word for the x coordinate of our brain buffs, of our vertex? What is the x coordinate, Charlie, of our vertex? Yes, it is. Axis of symmetry. So AOS, or axis of symmetry, is our x coordinate of our vertex. Last is plus k, and so we know that this is just if we're shifting up or down. So if it looks like this, that means take the function and shift it up. And if it's minus k, we know to shift down. We also know it's our y coordinate of our vertex. And for a brain buff, who can tell me what the y coordinate of our vertex means? Or what's the vocabulary word? Words for a y coordinate of our vertex. Anyone know? That's x-intercepts. Anyone know what the vocabulary is for the y coordinate of our vertex? Starts with M. Raise your hand so you can get a brain buff. There's the M. There are 2 words, this or this. Max or min. So max or min is the y coordinate of your vertex. So now we're going to just kind of put this in action, right? We're going to look at some equations, 2 equations. Yeah. And we're just figuring out the shift. So down here where there's like 2 boxes, here's our example 1. And so I'm going to write it so it goes along this with this. Y equals 2 parentheses x minus 3 squared plus 5. There it is, friends. So our first example looks like this. Y equals 2 parentheses x minus 3 squared plus 5. So let's break this guy down, right? First of all, is this a positive Patricia or a negative Nancy? This too. Positive Patricia, right? So we know it's going to be going up. If it's going up, is there going to be a min or a max? Min, right? So we know there's going to be a min. So we know that this is going to be our min. And we also, since it's a number that's not a fraction, is the function going to get narrower or wider? narrower, right? Narrower, I know, it's a weird word. So because it's a whole number, it would be narrower. If it was a fraction, it would be wider. Then we look over here at our h, right? And so right here we see -3. And so what direction is it shifting? Right 3, right? So we're shifting 3 to the right. We also know our axis of symmetry is x equals 3, which we know our x coordinate of our vertex is going to be over here. Not this one, that would be your x-intercept. The y coordinate of your vertex is this right here, right? So this means we're shifting up 5. And we know our minimum, because we figured out its minimum from that leading coefficient, is when y equals what number? So our vertex would be 3. Which we learned vertex already. We're just learning like y. We're just moving things around. Does that make sense? Cool. So I'm going to do one more example. Did you guys want to try it on your own in pencil and figure out what the shift is for each, and then we'll go over it? Do you guys think you could try one on your own? Okay. So the second example is going to be y equals. Yeah, and make sure do it in pencil. If you don't have one, I'll give one to you, just in case you mess up. Is y equals -1/2 parentheses x plus 5 squared -2. So see if you can try that one. The one right underneath it, like in that box, and see if you can give it a try. So try the next one on your own. See if you can figure out, okay, it's a fraction, so what does that mean? If it's negative, what direction is it going? You can also always type these into your table and type x squared into your table and figure out, okay, what's the difference between x squared and this to see, make sure you understand what's going on. Beautiful. All right, for a brain bug, who can give me one of the shifts? Charlie, give me one of them. Down. We know it's down because our negative Nancy means we're going down. And it's a max. Beautiful. You did, yes. What did you say? Yeah, why? That's just the equation. So like if you were to type it into your calculator, like that table.
Wider.
Oh, wider. You're saying why? Yeah, she didn't give you that one. You can give me that one. What is it? Wider. So we know it's going to go down. It's going to be wider, and it's going to have a max. Beautiful. Who can give me another one for a brain bug? Jalen, go for it. Beautiful. Shifts 5 to the left. What else about it? that our axis of symmetry, what is it? It's when x equals what? -5, right? Because it's the opposite. And so when shifting left, it's actually going to -5. All right, you want to give me the last one? Only when it's in the parentheses it changes. So if it's -2, see how this was going up 5? What would this one be going? Down. How many? 2. It's going down 2. And we also know that our max, because Charlie told us that, is when y equals -2. And that would be my reference. Does that make sense? Okay, cool. You're delta math for this, which I don't have a computer today, so I'll give you time to work on it a little bit next class. It's just it will tell you the shifts that they want done, and you're going to need to write the equation. So, so how many people would rather do it as like a group, like whiteboard game? How many people would rather just work on the packet and do like drill and kill? So how many people want to do the whiteboard game where we're doing different ones and beating each other? How many people want to do the whiteboard game? I mean, how many people want to do just drill and kill in the packet? So decide what you want to do. I'm going to take the drill and kill in the packet and make it as like a whiteboard game. And like you can write it down just for your sake. And so what you're going to do is I'm going to have you got your team a whiteboard and a marker, and we're going to be going over it. Top team will get candy. Okay. And we're just going over these different ones. So if you would rather just do it on your own, that's fine. Yeah, I'm probably just going to have I'm just going to have you do shit. Yeah.